In this lecture, we will discuss about the logarithmic and exponential differentiation. So let's say we have the function f of x given by e raised to the power of x. Then its derivative with respect to x is simply e raised to the power of x. And if we have g of x is equals to the natural log of x, then derivative of g of x is 1 over x. Now, this will become extremely useful, especially the logarithmic differentiation. For instance, here we have the exponential function given by e raised to the power of x. Now, suppose we have the function h of x equals to, instead of the exponent e, we have some constant a raised to the power of x. The question is, what will be the derivative of this particular function with respect to x? So for this, we are going to assume, so let's say y is equals to a raised to the power of x. Now we'll take the logarithm, the natural logarithm on both sides. So this will be natural log of y equals to natural log of a raised to the power of x. Now we can use the property of logarithm, so we can bring the x and multiply it to log of x or log of a. So that means we have log of y equals to x times natural log of a. Now we will differentiate both sides with respect to x. So we have derivative with respect to x of log of y, which is equals to derivative of x log of a with respect to. For taking the derivative of natural log of y, we have 1 over x, but here we have log of y instead of x, so we'll have to use the chain rule. So this will become 1 over y, but we need to multiply it to the derivative of y with respect to x equals to log of a. So log of a is a constant that will be multiplied to derivative of x with respect to x. So this gives us 1 over y times derivative of y with respect to x is equals to natural log of a times derivative of x with respect to x, so that is 1. dy over dx, the derivative of y with respect to x will be simply y times log of a, and replacing the value of y with e raised to the power of x, so we get a raised to the power of x times natural log of a. So this is the derivative of a raised to the power of x. For instance, if we have derivative with respect to 3 raised to the power of x, so this will be 3 raised to the power of x times natural log of 3. So let's try out few problems. Let's say we have the function given by f of x is equals to 8 times 3 raised to the power of x. So what will be the derivative of f of x? So f of f prime of x, which is derivative of fx with respect to x. So this is 8 times, 8 is a constant, derivative with respect to x of 3 raised to the power of x. So this is 8 times, the derivative of 3 raised to the power of x will be 3 raised to the power of x times natural log of 3. Or we can write this 8 times natural log of 3 multiplied to 3 raised to the power of x. So this is the derivative of a given function. Let's move on to the next problem. So we have the exponential function e raised to the power of tangent of 5x, and we need to find its derivative with respect to x. Derivative of the exponential function. So here we have to use the chain rule. So we'll assume the tangent of 5x, so that's x. So derivative of e raised to the power of x is simply the function itself. We have e raised to the power of tangent of 5x. Now we will need to apply the chain rule to it. So this will give us derivative of tangent of 5x with respect to x. So tangent of 5x is going to give us secant squared. So 5x will be treated as x, 5x multiplied to derivative with respect to x of 5x. So we have e raised to the power of tangent of 5x times secant squared 5x times 5. So this is the final answer. There is another way we can try it out. So let's say y is equals to e raised to the power of tangent of 5x. We can take the logarithm on both sides, so that will give us logarithm of y equals to natural log of e raised to the power of tangent of 5x. We can use the property of logarithm and bring the tangent of x to the front and multiply it to natural log of e. But we know that the value of natural log of e, that's always 1. So we have log of y is equals to tangent of 5x. I will take the derivative on both sides with respect to x. So derivative of log of y will be 1 over y times dy over dx. And this is equals to derivative of tangent of 5x. So here we'll have to apply the chain rule. So this is secant squared 5x times derivative of 5x with respect to x, which will be simply 5. Now dy over dx will be, so we will multiply both sides with y. So we have 5 times y. So we will replace the value of y with e raised to the power of tangent of 5x times secant squared 5x. So here we can see we have obtained the same result if we use the exponential differentiation or we use the logarithmic differentiation. Let's move on to the next problem. So we have an exponent form of a function which is x raised to the power of x. So it's given that f of x is x raised to the power of x. So we will consider that y is equals to f of x, which is equals to x raised to the power of x. So we'll start with y equals to x raised to the power of x. Let's take the logarithm on both sides. So that will give us logarithm of y equals to logarithm of x raised to the power of x. So we can bring the x to the front. We'll have log of y equals to x times natural log of x. Now we will apply the derivative with respect to x on both sides. So this will be derivative of log of y with respect to x times derivative with respect to x of x log of x. Derivative of log of y with respect to x. So this will be 1 over y times dy over dx. Here we have applied the chain rule. Equals to, for the derivative on the right hand side, we have to use the product rule since we have two functions x and log of x. This is x times derivative with respect to x of log of x plus log of x multiplied to derivative of x with respect to x, which is 1 over y times dy over dx equals to x times natural log of x. The derivative is 1 over x plus log of x times derivative of x with respect to x is 1. Finally, we get dy over dx is equals to, we'll cross multiply with y, so x divided by x, so that's simply 1 plus log x, and the value of y is x raised to the power of x from equation 1, which is x raised to the power of x multiplied to 1 plus natural log of x. This is the derivative of our function x raised to the power of x. Problem number 4, we need to verify the power rule in differentiation using logarithm. So let us begin. Where you have the function y equals to x raised to the power of n. From the power rule, we know that derivative of y with respect to x is given by n times x raised to the power of n minus 1. So this is what we need to prove. For this, we are going to take the logarithm, the natural logarithm on both sides, which will be log of y equals to log of x raised to the power of n. Using the property of logarithm, we'll bring the n to the front. So this will get multiplied to log of x. Let's take the derivative with respect to x on both sides. So n here is a constant, so it will be pulled out of the derivative, natural log of x. Derivative of log of y is 1 over y times dy over dx, which is equals to n times derivative of log of x is 1 over x. This gives us dy over dx equals to n times y divided by x. So we will replace the value of y with x raised to the power of n divided by x, and this is simply x raised to the power of n minus 1. We've used the laws of exponents to combine the two x in both the numerator and denominator to get x raised to the power of n minus 1. And this proves the power rule in differentiation.